In this part of the lecture, I would like to show you how Swimmer works. In order to download the code, you can link to our folder on GitHub. This is the link. Our folder is called the Sporting Code, and here you can find all the code we developed in my lab. And if you want to download the code of Swimmer, you click here. And here you have the user guide. And here you have the code. And so you have to download this folder. Okay. Once you download the folder, okay, no, sorry, before that, some words in order to explain how Swim works. Swim is the first version of Swim is developed in MATLAB, but here on GitHub you can download the second version of Swim that is written in R. And Swimmer consists of 4 modules. In the first module, we have the exploratory data analysis, in which Swimmer imports the data matrix and performs the pre-filtering and filtering phase. At the end of this step of this module, you have a list of different size-specific genes between 2 conditions. Then, in the second module, Swim performed a network analysis in which it built the correlation networks and finds community in the network by using k-means. And in the third module, Swim built the heat cartography maps, assign a role to each node in the network, and finally it identifies with genes. Then there is also an optional module that is called resilience analysis, in which Swim evaluates the network the resilience after the removal of hubs, non-hubs genes, and switch genes. But for the details of this module, you can refer to the user guide. Okay, here the main publication on Swim. In the first publication, you can find the first version written in MATLAB, and in the bioinformatics one, you can find the R version of Swim. And here the link to our Sporting Code folder. Swim required as input data matrix a gene expression data matrix of normalized counts. For instance, if you use RNA-seq data, this is an important caveat. Swim doesn't perform any normalization like FPKM or whatever you want. You have to normalize data by yourself, and then with the normalized data, you can run Swim. And what is important is you have 2 conditions, for instance, normal tissue and tumor tissues, or treated and untreated cells, or whatever you want. And starting from the whole transcriptomic data, you arrive with a list of a small pool of switch genes. Okay. Okay, Swim has been tested on these operative systems, and in order to run Swimmer, you have to install R and R Studio. and you have to download the software package from GitHub. You have to unzip the folder, and then I'm going to explain how you can use Swim. Okay, you can download the code folder from GitHub, and when you click on the folder, you unzip the file, and you have this source folder as per RC, in which you have all the script, but you are not required to open the folder script in which you have all the library of Swim. You have just work on the main file in order to set your configuration parameters. And then you have the folder named project in which you can put all your project. For each project, you have the folder dataset in which you can put all your dataset. And then for each dataset, you have to create two folders named list and matrix in which you can put your matrix and the list of your samples. I'm going to explain in details all these steps. What is important is that blue folder are you have to create the blue folder, and the name of this folder are mandatory. And you have also to create also the yellow folder, and the name of the yellow folder is your choice. And for instance, if you want to work with the data from the Cancer Genome Atlas, you can call your project TCGA. But inside this folder, you have to create a folder with a mandatory name that is dataset. And inside this folder, you can create how many folders you want, and you can give to this folder the name you prefer. For instance, if you want to study the breast cancer data from the TCGA, you can name the folder BRCA, or if you want to study prostate cancer, you can name these with the acronyms of prostate cancer, and so on. What is important is that inside each folder, for instance, BRCA, you have to create two folders with the mandatory name that are list and matrix. In the matrix, you have to put your gene expression data matrix, and in the list, you have to do two files with the list of the sample for each condition you have. Okay, after running Swim, you will end up with two other folders, filtering and switch, that will be created by Swim, and an R file in which you have the summary of your running that is created by Swim. In the filtering phase, Swim will create three different folders, one that is called figure, one that is called txt file, one that is called R data. And in the figure folder, you have all the figure produced by Swim. In the txt file, you have all the file in txt format, and in this folder you have the same in R files. For the details of each file, you can refer to the user guide that you can find in the GitHub, in our GitHub link. Okay, and so we can start with a toy example that is the BRCA. In the folder named matrix, you have to put the data matrix. of gene expression. And in the list folder, the data matrix is like this, in which you have colored in red and in black the tumor and normal tissue, for instance. And in the list folder, you can put the list of the sample into different files. For instance, the condition A in one file, and in another file you have to put the condition B, for instance. Okay, this is the main folder. When you can open R, you can click on the colder folder, and you then click on SRC, and here you can find the main file, and it appears like that. Okay, this is the working directory, and if you click on the script folder and then on the input folder, you find the config files, and these are the two files in which you are required to act. In here, you have to change the name according to your project and your data set. Okay, and here you have the name of your files, and so you can change this name if you have another name for the matrix, another name for the two list. And this is the same if you have also microRNA. Here you have all the parameters that you have to set in order to run Swim. These are the parameters for the exploratory data analysis, for I2R, for the false change, for the adjusted p-value, and the same for the microRNA if you have the microRNA data. And these are the parameters for building the correlation networks, and these are the parameters corresponding to the K-means algorithm. And these parameters regard the 4 modules, and so I suggest to set this parameter to no, to false, if you don't want to evaluate the network resilience. That will take a long time, and so I strongly suggest to don't focus on this step for your first application of Swim. And after setting the parameters, you can start to launch Swimmer. And okay, that's it. And if you have any question, you can ask me when you want.